Hello, Mr. Lee here. All right, so today we're going to be looking at exponent properties. This table on the left here is the same table you have on your Canvas page. Keep referring to it. You can actually start applying these properties. But this video is going to be a short video giving you some intuition where these properties come from. Okay, so essentially kind of mini proofs. Let's look at the first property, the product property. And if you look at the example, I'm going to rewrite it here. We have 3 squared times 3 to the power 4. Okay, so it's kind of laid out for you in the example, but to break it down even further, right, the reason it works is because if you have 3 squared, that's a total of 2 threes, right, being multiplied. If you have 3 to the power 4, that's a total of 4 threes being multiplied. How many total threes do you have being multiplied now? 6 of them, right? So that's where this whole you can add the exponents rules comes from. Okay, so that is product property. I'm going to go through some of these fast, so you can definitely rewind the video if you need. Quotient property, right? The example is x to the power of 5 over x to the power of 2. Okay, so I'm going to do something very similar. There's going to be 5 x's total being multiplied at the top, and then 2 x's total being multiplied on the bottom. So we can kind of cancel out some of these, right? X divided by x is just 1. Another x divided by x is just 1, so you're left with 3 of them. Right? So that's where the whole subtraction of these exponents come in with your quotient property. Okay? Now, for the next two properties, property of 0 and property of negatives, we're going to do a little exercise here and essentially develop a pattern to understand where this whole power of 0 and negative exponents actually give you these values. Okay? So let's take a number 3 and let's raise to the power of 1. Right? So that's obviously going to be 3. If you have 3 squared, that's going to be 3 times 3, which is 9. If you have 3 to the power of 3, you multiply that by another 3, right? 3 times 3 times 3, that gives you 27. Okay? So I'm going to change colors here. Let's get some red going. So if I figure out the pattern of these exponents, right? I mean, this is kind of the definition of exponents. If you have 3 to the power of 1 and then you have 3 to the power of 2, the comparison of it is you multiply by an extra 3. Right? And then if you have 3 squared to 3 power of 3, you're going to multiply that by an extra 3, right? So the same is true if you go backwards. If you're multiplying by 3 to the right, that means if you take 27, you want to get to 9, we must be dividing by 3, right? If you're getting to 9 and going to 3, you must be dividing by 3. So there's no reason to believe that the pattern is going to change even when we get to these 0 and negative exponents. Okay, so check it out. I'm going to switch the color here. Let's go now to your 3 to the power of 0. Right? 3 to the power of 0. We're going to take this 3 and divide it by 3. Sorry, my colors are kind of off, but you got the idea. So I'm going to divide it by 3, which gives me a 1. Right? So anything to the power of 0 is equal to 1. That's where that comes from. You can test this with any other base, right? 4, 5, 6, doesn't matter. You'll still get 1 in this position. Okay? So now let's keep going. 3 to the power of negative 1. We're going to take that 1 and still divide it by 3. So that's going to be 1/3. Another way to write it is going to be 1 over 3 to the power of 1. There's this relationship with having the negative exponent being a positive exponent once you flip it as a fraction, right? So 3 to the power of negative 1 is the same as 1 over 3 to the power of positive 1. And then we keep going here, right? And by the way, you can check all this on the calculator, open up Desmos, and see that I'm not lying. 3 to the power of negative 2 is going to be this 1/3 again. We're going to the left. We're going to divide it by 3. So 1/3 divided by 3 becomes even smaller. It's going to be 1/9. That can also be written as 1 over 3 to the power of 2, right? So again, 3 to the power of negative 2 becomes 1 over 3 to the positive 2. All right, let's do one more. 3 to the negative 3, same thing, right? We're taking that 1/9. We're going to divide it by 3 again. So 1 over 27 can also be written as 1 over 3 to the positive 3. Okay, so there's some intuition for these 4 properties that you'll be applying. Let me know if you have any questions.